Hello again. Hello again. Happy Sunday. Welcome to class number 12, believe it or not. Um, that is what we've got here. CICD. So we are continuing from where we left things yesterday. Obviously, yesterday we started talking about CICD as continuous integration and continuous delivery or deployment. We looked at the introductory side of things, what it's about, why we need it, and the complexity, the complexion it takes. So it comes in different shapes and sizes, as we mentioned yesterday. We went as far as looking at Jenkins as one of the major CI/CD tools. We did say there are quite a few of them. Um, Not least Jenkins, Azure DevOps, AWS Code Deploy, Bamboo, GitLab, GitHub Actions, list goes on. So we did we wrote a couple of pipelines in different forms. So we're going to take off from there today to extend the complexity, the inevitable complexity of the pipeline. So what I'm going to do is I'm gonna get us to where we were yesterday. I have to apologize. I just created a new instance. Probably gives us an opportunity to look at this thing again. So I just created a new instance of Jenkins. I just terminated the old one. So I'm gonna try and connect to this and I just bring it up. It's all set up, I believe. And yes. So this instance, I basically just stood it up. We go to security, just make sure port 8080 is configured on it. May have done that. I'm just going to double check that. Okay, so it's good. So I think I'm almost there in terms of setup. So I will select it and I'm going to test my Jenkins. I can use the public DNS or the public IP address. So let's go. So I'll do that. Install 8080. Boom. Okay, I expect this to pop up. I don't have this, so I'll probably copy that. I will go on the machine. I will connect. And I'm just going to source that out by using sudo cat to look at the file. And that should give you the key. Copy that. Bring that here. Continue. Not now. And I'm going to just do basic plugin installation. So while this is sort of going on, I'm just going to do a recap of where we left things yesterday. So we were playing with obviously setting up Jenkins system, and the first thing we wanted to attack was creating our infra. So we did say that Jenkins is not the most intelligent tool there. You have to tell you exactly what you want and the steps that you need to take that it needs to take to achieve that. So it's just a system that allows you to automate what you already have. So in terms of what you need to do, what you want to do, you have to basically define it to Jenkins. So be it your Terraform, be it your Git, whatever else things you need, you have to have the scripts, you have to have the binaries, and so forth. So we also mentioned that Jenkins has plugins that makes it easier to interact or use binaries. For example, things like Git, things like Terraform, you can have certain plugins that plugins that make it easier to manage those binaries. So the first thing we're going to look at, which we're already looking at yesterday, we did create our first, hello world pipelines here and there. I guess to get into the meat of the matter is we want to create our first infrastructure using Jenkins as the mechanism to drive the infrastructure creation. We already have the script in our repo here. That's what we're looking at yesterday. So we are going to redefine and redesign this quickly. just extend a little bit. We'll probably maybe what we have already, and then try to extend it a little bit. Some things might fail. We'll find a way to do with them as we go on. Okay, so first task is set up Jenkins properly, and the next task will be to access that repo and then use Jenkins via Terraform to provision the system that this particular different. I think in here is just one single system. So that's what we're gonna try to do and get that sorted. Okay, what we're going to be talking about is more of a general concept. What I mean by that is today we may be using Jenkins to interact with Terraform and Git. Tomorrow it might be interacting with Packer, interacting with other binaries. So the concept will be the same. Okay, so if you've seen if you've seen Jenkins work with Terraform, you should be able to use the same mechanism to make your Jenkins work with Packer or make your Jenkins work with Git and not the rest of it. If you understand the concept, you should be able to adapt the concept to any binary that you want to use under the hood with Jenkins. So this in our case now, it's going to be with Terraform to stand up our infrastructure. So without much ado, let's get started. So we have the plugins installed. This is all bread and butter. Now, and then finish. And then start using Jenkins. It's all good. Nice and easy. You're going to have this teething problem, which we are going to deal with. So build executor. We go to build executor. We go to monitor. That's it. And then we go to configure to just get rid of this inevitable 1 gig challenge. So we go to disk. We talked about this yesterday. Probably just say 100 MB just to get this out of the way. And then we're good. And then bring this back online, bring this back online, and then it's online. Right. So just to kind of kick the tires, flush the system, let's create a simple job to make sure this is working. Just say hello, freestyle project. Okay, we go here, say execute shell. We just say something like echo hello world. Just apply, save, just to make sure that we test that the pipeline is working okay. Okay, so this is all good. We know we have a good system now. Okay. So now going back to the challenge. So what we want to do, obviously in this case, is we want to use Jenkins. Just go Jenkins here. So we want to use Jenkins to so the Terraform code we have, which is this one, which provisions the system. This is just a single simple system for us. I don't think I have the AMI anymore because I use Packer for this, so it doesn't matter. I'll probably change that because it might fail. But it's just about looking at the concept. So this code creates a machine which is Nginx node with already pre-prepared, I suppose, pre-prepared Nginx installed and some file somewhere, etc., which was what I created. I think I may have deleted the AMI just to save space. I will check. So this might not work because this AMI no exists. But that aside, it's not really a problem. The objective of this next exercise is not really to kind of, hone in on web server creation, but generally about the concept of, running Terraform via Jenkins. Okay. And that's what we're going to focus on first and foremost. So what probably we would do just for this exercise is we have the Jenkins machine here, right? So what we're going to do, we're going to serve up this link. So Jenkins will read the Terraform code from GitHub. this GitHub Terraform code ready into Jenkins. And in here, so Jenkins, we will then do pipeline to create a machine. Okay, let's make that a little bit bigger. And this pipeline will now give birth to this pipeline will now give birth to a machine. So this is what we're gonna do. So we kind of forget this voice. Let's see, yeah. So this is what we want to achieve. It's a very small objective, obviously achievable. So you're gonna read the code which is here. We're gonna put that into Jenkins. To do that, obviously we need Git already or installed on this machine to be able to do the pull or the clone. Then after that, we need to then get into Jenkins to then execute Terraform to then create the machine. So we're going to leverage this code. This code might need some sort of tweaks here and there, some readjustment, but we're going to kind of figure that out because we're not really focusing on that for now. Okay, so let's get to it. So first thing we want to do is we know we already have the Jenkins, the Terraform code already on our system. So that's not a problem. So we can always leverage that to create what we want to do. So the first objective will be to begin to write the pipeline. Then we kind of, let's see. Let me find this. Please bear with me. Okay. Okay, cool. Right. They're just going to start from scratch there. I couldn't find it. I'm trying to see if I can find the thing we worked on yesterday, but I can't find it. Anyway, let's do it from scratch. Doesn't matter. So we have the Terraform repo here. So we have the Jenkins pipeline here. So we're just going to go here. We're going to start from scratch. Remember, the objective is to create a machine using Jenkins. By logging onto the machine and doing remote stuff, we're going to see that much later. So let's get to it. Right. So we have the Jenkins system here. We're going to go a new item. We're going to, in this case, let's call it Terraform pipeline. Remember, we don't have Git installed yet. So that will give us problems, but we're going to kind of build together along, and when we encounter this problem, we're going to deal with them together so we'll understand why we come across this problem and the remedy to those problems. So we create a Terraform pipeline. That's not what we're going to call it. And then we say, okay. And then we begin. So we come here, we want to use Groovy pipeline. So we'll say pipeline. And then we'll begin our pipeline. We're going to say agent any still. And then we'll begin our stages. So stages. And then we're going to say stage. This is git checkout. I'll call this git. Git checkout. And then we'll begin. And then in here we'll have steps. And in here we're going to use the Git plugin. So we're going to say Git plugin. We're going to specify our branch. Okay, someone raising their hand. All right. Let's see, who is that? Let's go for it if you're raising your hand. Let's see.
I raised my hand before, but I dropped
Okay,
it. Can you hear me?
I can hear you. What's up?
Okay, thank you. It was around when you were configuring Jenkins, where you
Mm-hmm.
have 1 GB before and it was throwing error and you reduce it to 100 megabyte. I'm
Mm-hmm.
just trying to, my question is around that area, and
Mm-hmm.
I want to know what kind of problem can actually come up because the system is suggesting that it needs 1 GB. I
Mm-hmm.
know that I've encountered some problems in the past whereby some is a workload or something
Okay, let
to
me
tell
answer the
me,
question. Okay, so
okay.
we don't dwell too much on it. So obviously, when you I'm sorry, by the way, I believe that we all understand what I'm doing. So I'm just trying to use one multitask a little bit. So um so essentially the system Jenkins uses the temp directory to do its dirty work. So it's just like a slab where the butcher would cut the meat and cut the meat into pieces and whatnot. So the temp directory is a place where Jenkins does his dirty work. If that place is not big enough, Jenkins could run into all sorts of problems. If it doesn't have enough space to play, which is the temp directory, it is suggesting that you need minimum of 1 gig because it doesn't know what your workload looks like. So it is just a recommendation. The problem you might run into if you run out of disk space is just your job will fail and you're gonna get the out of disk space error, and then you know that you run out of disk space. So it's not really going to be something that will be catastrophic, especially because we are like in a non-production system. In a production system, obviously you will not be using this kind of machine. So the worst problem you're going to run into is running out of disk space, which obviously you then deal with by deleting files, etc.
So
Is
in production environment, what do you recommend?
in the production, you need a big system. You need a huge machine. You're not going to be working with a 1 gig machine. So you need a machine with big space. And then you will have to have an aggressive cleanup system. The other option is to tell Jenkins not to use 10 as his temporary directory. You can override that and say
Volume.
use another directory instead of 10.
Okay, thank you.
You're welcome. I'm hoping that what I'm doing here is not anything special. So we've seen this before. So blah, blah, blah. So we're doing URL, git, steps, stages. What does it mean? Like expecting git branch. Okay. Steps. Start, branch, name. Yeah, all looks good. Okay, cool. That was just a trend. So this should help us to hopefully have the machine created. I mean, sorry, have this stuff downloaded, and then we can then from there essentially so that's steps. Then just double check that. Right. Hmm. Why is it showing red there? I'm just thinking, what was it not like there? And so that is that step. So this would help us download it. We expect this to fail, by the way. So let's just run it one step at a time. So this will fail because we don't have Git in the system. So we'll apply, save, let's run it. This will fail because there's no Git on the machine, except I've installed it, which I doubt. Okay, so this fails. So when you are testing and you come across this problem, could not do telephone, blah, 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 no spy, no such file directory, GitHub. Basically, it couldn't just do Git command. It's no, you couldn't do it. So what we do, we've seen this before, I haven't lost the session yet, which I have done. So I'm going to reload that session. Connect. Connect. Okay, this pops up. So what we do is we're going to say sudo yum install git. Okay, I think I got that one on -1. Okay, cool. So while that is going, we know that that should help us with this now. The solution is complete. Okay, it's all done. So if we repeat the pipeline process now, just say replay. We should get some joy this time. I think it's failed again. So let's see why it's failed. Console output. Maximum attempt rate. Okay. HTTPS. What did that mean? Okay. HTTPS not supported. What have I done wrong? Let's have a look. Pipeline.
Check the URL you passed.
Sorry, say again.
I see the URL you passed.
Yeah, this is the problem. See that? Yeah, the error. Yeah, let me show you the error. So let me correct this. Let's look at the error. This is the error. I think I wrote HTTPS twice. So I just see that it's just a typing error. It should be 1. So then this should just rebuild, replay, and okay, this is still showing. Okay, let me not do replay. The problem with replay is you remember the old code. So if you go back, don't do replay. If you build now, it will take my latest change because the old code obviously had an error in it. So if you kind of start, kind of take a peek into that, this is all going now. It's good. And then you can want to look at the pipeline overview. It's just one step. Git checkout. So what we want to do next is obviously do the Terraform bit, which is after we downloaded the code, we want to match it into. So when we download the code, we know we are going to find ourselves in this directory. So we're going to find ourselves in Packer Terraform after that code is downloaded on the Jenkins machine. Okay, so how do we know that? We can have a quick look. Let's go back and go to console and configure that. So if we go back, okay, and do something like sh ls-ltr to see what we get. Apply, save, save now. Okay, if you look at the console, that will tell us, yeah, after download, it says Terraform and Packer. So obviously so this is what it says, Terraform and Packer. So what we need to do is get into Terraform and then do all the Terraform shenanigans that we've always done. Okay, so we're going to put that in the pipeline. And we'll say pipeline, edit, configure. So the next stage, this is that stage, which is stage that. And then we'll do another stage. So we're going to say stage for this stage. We're going to say, let's do some Terraform formats. This is just to format check or even validate. Let's do validate instead of just validate code before we run it. Yes. Let's do Terraform validate. This is all new to us because we looked at this last week. Of course, we're gonna keep exploring Terraform as we go along. So steps. So here we need to jump into that directory, which is the Terraform directory. Remember that when we do the code download, we're going to find ourselves here. So we need to change directory into this one. And then this is where the Terraform code is. So that we need to reflect that in the pipeline. So we can say start directory of interest is I think it's called Terraform. Okay. Directory of interest is Terraform. So in that directory, what do we want to do? We can say we want to run a command which is Terraform validate. Just to validate the code. I expect this to fail because we don't have Terraform on the system yet. Okay, so this would fail. Then we'll have to install Terraform to then do the validation process. So let's run this. This would fail, but we will then install Terraform. So as we kind of go along, we'll see what we're doing to, tackle all these problems. So run now. Okay, this is failed as expected. Let's have a look. So output. So Terraform command not found. So we're going to install Terraform. Okay. So to install Terraform, let me find the instruction real quick. Okay, so I should copy this. Okay, cool. Got the instruction. Just put the repo down. Okay, copy. So we go here. I hope this is still valid. Okay, cool. Paste that here. Okay. I'm just gonna have the. Okay, I'm gonna say sudo install Terraform. And then say yes. Okay, Terraform is going to get installed. Say Terraform version. Okay, that's good. So if we go back to the pipeline, if we run it again, build now, that hopefully comes back, right? Okay, this is filled again. So output. Okay, so I need to run Terraform in it to do blah, blah, blah. Okay, so now the thing we validate is that it requires us to do some initialization and whatnot. So I'm going to explain this. We'll get into the meat of the matter. So what Terraform is saying now is, you need to do some authentication. I don't know. You haven't provided me a provider. I don't know how to authenticate. I don't have all this information. I'm not happy. So we're probably gonna so let's do the init first and then kind of follow the normal course of processing doing Terraform. Terraform init, Terraform validate. That potentially also would fail because of authentication information. And then we're gonna look at how to do authentication with Terraform. So if you have any questions as you're going along, so I know I'm appreciating you might not have questions now, but whenever you have a question, just feel free to stop me. But just bear with me now. I will try and explain everything. So I'm kind of doing this so that you see the error I get into, why I get into them, and how to deal with them. So we go back here, and then we do configure. Okay, so let's start with Terraform initialization. So let's say Terraform initialization. So let's do Terraform init. Let's see that first. And I'm going to tell us the big change we need to make to get this working. Okay, where are we? Let's run. Okay, I think let's have a look. Yeah, I think his run is just stressing the system because of it's a low profile machine. Let me see. Yeah. So we'll wait for that to come back. So we know that Terraform init usually takes a bit of time to work through because it needs to download. So essentially when you're doing the init, Terraform basically looks at your the plugin you specify and it's basically downloading, and that takes a long some time. But hopefully this comes back intact. The system is strong enough. So by the way, if you are like, okay, this is still taking up. So if you want to see what is kind of happening at system level, if you go to monitoring, which is very interesting, you will see how much stress the machine is going through. So if you say the last hour, you can look at CPU utilization. Okay, it hasn't really jumped here. Let's refresh. You might see some interesting change. Okay, so so I'm looking at this and I don't see much stress on the system. So let's look at it. Is it back? Yeah, the machine is really struggling. Yeah, I see it's not responsive, it's struggling. Hopefully it comes back. Otherwise, you might have to get a bigger system. So the Terraform init is stressing it. And this is one of the downside of using a small machine. Let's see. Monitoring. It's not even giving any monitoring stuff against that instance running. Let's do systems and alarms. System checks pass. Matrix. So it's not really reporting anything of note yet. Let's see as it come back. This is not looking good. Let me try and connect, which I think I would. I don't think I'll succeed, but let's try. I might have to create a new machine if we are unable to reach this one. I think this might be a lost cause. I won't expect them to connect to it. I don't think I've used a T3. I've used a T3 for Terraform before, definitely. So why is this different? Okay. Yeah, we've lost connection to that machine. You can see we can't even connect to it. I might use a bigger machine. I'm worried that you guys only have access to the free tier ones. And I don't want to use something that will cost you if you want to use. Yeah, this is struggling, which is very strange.
You
Okay.
in it.
Sorry?
I said the machine is overworked.
Yes, it's struggling. Okay, cool. I'll tell you what, let's pivot a little bit. Let me see if you can use another machine. I think combining Jenkins, because if we just run it without Jenkins, it probably would work. But Jenkins with Terraform is probably too much for it. Let's see. Okay, so let's get a bigger machine. So let's launch a new instance. Let's do that real quick. So the one we had before, let's just call this Jenkins. Bigger Jenkins. Jenkins 2, maybe. But what is important is here. So what we had before is a 2 CPU, which is not a small system. I think it probably might be struggling on memory. But I don't know because it's not even showing any, it's not giving us any updates for now on what it's not happy about. And this is, we can't even connect to it anymore. And this back? No, this is dead for him, I suppose. Or I'm gonna find a bigger machine, and I don't want to use something that is not free tier eligible, so that you won't have to pay. You don't have to pay for it if you want to pay this. Let's see. So the options we have here is let's see. So the T2 macro is V1 1 GB 1 GB, and T2 macro is even more than T1. And this is a T2 small. This is probably the one that would do it, but I don't think it's free tier eligible. So you might not be able to get it on that free tier, which would be a shame because I want to be able to practice without paying for it. Let's see. I'll tell you what. Let me just do this for demonstration for now, so we are not kind of hung up on um, infrastructure being the problem. I'm just gonna get a bigger machine. We're gonna do it, and then I'm gonna see if there's anything we can do um, to get to use a smaller machine, which I really doubt, but it's what it explains. Cool. So let me look our last one check and see if this machine has come back. It's definitely not come back. It's stuck. So sadly, I need to find just another system. I'm going to use it. I don't even know if it's a CPU problem or a memory problem. I suspect it might be memory problem. So I'm going to get a 4 GB, which is the one we're using now. It's a T3, which is 2 CPU, T3 micro, 2 CPU and 1 memory. So if you get a 2 CPU and 2 GB memory, that should work. So we're going to use a T3 small instead of T3 micro. Let's use that real quick. So we're using a T3 small instead of T3 micro. I'm going to speed things up because it's going to be more of the same thing. And launch. I'm still checking this, holding out up. It's an hopeless situation, but so that is a bit hopeless. So this comes back, let's connect to it, and let's quickly get moving. Okay, we'll connect. So this is like a new machine we want to prepare as our Jenkins machine. Connect. I'm gonna really rush things. It will be basically what we've done before. So please don't fret too much if you see me doing a sort of things that I have not talked about. It's just to save time real quick because it'll be a repetition of all this. So first and foremost, I'm gonna quickly enable port 8080 here. Go security. And I'm hoping that this also will not collapse under me because that would be a disaster if this one has to. Okay, cool. Edit. I'll draw 8080. Okay, save rule. That's done. Go back here. Okay, this one is dead. Let's just close it. Okay, close that as well. Okay, cool. So this is the new guy. So I'm going to just haul my commands real quick there to have the system provision real quickly. Where is this command? Do I have them handy? I doubt it, but let me check quickly. Yes, I shared in the group yesterday, so I'm just gonna harvest it from that group. Command used today. Okay. So these are the commands I'm just gonna do. I'm gonna do them. Don't all the things I'm doing, I don't worry about it too much. It's just me trying to GG. Whatever I'm doing now, please just ignore it. run the commands, just gonna run everything. So this should do the installation for us, and this should be a little bit quicker. It's more memory, same CPU, but more memory. And I'm still hoping that this comes back. I think it's hopeless. Okay, that's hopeless. Okay, so this is doing all the installation it needs to do now. Okay, so we've got everything we need. And I'm just gonna wipe.
There are suggestions on the chat on what they
Yeah,
think.
we can't save that system, honestly. If you can't connect to it, you can't save it.
Okay.
Let's not worry about it. You have to be able to connect to it. So restart it. If you restart it, it's gonna run same problem. Let's install that. While that is ongoing, let's install that. Blah, blah, blah. So sudo yum, I'm gonna install Git as well. Yeah. What? Already installed. Okay, cool, cool. So we go Git. We're trying to digest install now. Okay, Terraform is installed. Git is installed. Blah 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 blah. And then I did run some cat thing earlier. So I wanted to see that one. Yeah, that one's done. Copy. I'm going to then go again. This is as dead as a dog. Okay. Right. So I'll close that one as well. So we go here. We get a machine name. Blah, 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 blah. Okay. We got instance. Just want to grab the public DNS name. Right, copy that. And then we will just use that. Use that here. Yeah. Just do that. 8080. Okay, that comes back. And then we'll get that one here. Yes. Go. Now, with the plugin installation. So while that is ongoing, okay. I need to think of how I'm going to be able to work with you to be able to use a free tier machine to do this test because I don't want you paying for stuff. If this machine holds up, it helps us, but it probably doesn't help you if you're not able to use a free system. So I might think of more creative way to help you. But at least let's just get it running. I'm just giving my fingers crossed this won't die on us as well. So otherwise, I may have to do some adjustment with the way we run Jenkins just to make sure that maybe uses less. I always try to not do something too complicated that you won't be able to do at home. There are many ways we can reduce the Jenkins requirements, etc. But if I'm doing something like complex, it doesn't really help with training. Okay, so this is all done. Okay, we've done this before. So we go here. Suspect it might actually be because of that temp space, but we'll see. Okay, configure. So let's threshold. Let's do 100 MB, 100 MB. Okay, maybe because of that. Let's see. It's not back online. It's not back on. If I have this problem again, I might have to pivot a little bit, but I suspect it might be due to space. Okay, cool. Right. So let's get to creating the job now. I'm gonna rush this a little bit. I'm gonna test that Terraform real quick to see if we're gonna go into that problem again. Just say Terraform pipeline. Tell you what I'm gonna do. Okay, let's begin this pipeline, but let's do a quick experiment. Okay, we know what the pipeline is gonna do. I'm just gonna show you that its problem is not really with the code, is with the pipeline system. So for example, we know this is the repo, right? This is what we want to do, right? All we want to do is download this repo using HTTP, which we have done many times. We would do that. So this is what we want to replicate. So I'm going to do it manually to just show us that the problem is not really with the code. It's just with the Jenkins system works. So for example, here, what we want to do is git clone that. So that is cloned, and then we'll seed into it. And then seed into Terraform, which is there. And what we are doing here is essentially Terraform in it. And this is what caused the problem. And this just goes to what it needs to do. And this is where it kind of died. Okay. So this is also, it's not a problem. This really works. I think it comes down to maybe using temp and all that, and it kind of run out of space. Let me just check the space just to make sure. So 10, this stuff in 10. Okay, cool. So let's go for it. And, hopefully second time lucky. Okay, cool. So we begin the pipeline. So I'm going to make it real quick. I'm just going to jump pipe. I can type first pipeline. And then we'll begin agent any of any. Yeah. And then we'll begin send stages. And then send stage. Let's just do it real quick. Checkout. And in checkout, we'll do steps. And then we'll do git. Then we do that. We do URL. What's the URL again? Grab it, grab it, grab it. Where is the URL? Where is the URL? Let me just copy it from here. Have a look here. Oh, and get back here. I'm going to talk about, just say EU on the O. What else? Is everything correct here? Okay, this is probably not correct. This branches name, comma URL. Yep. So this should be it. Steps. Check out. Okay. Does it not like that? Okay. It's missing. Stage steps. It branches the URL is there. Put in another line. Why is it showing red there? What am I missing? Okay. Check out stages. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. So why don't you like that apart? It was good. Okay, let's run it here now. Okay, it's just chakra. It was good. Okay, right. So this does what we need to do. Now today to the biggie. So we go here, we go configure. I'm holding my breath. I don't want that thing to hang on me again, but also. So this and then the next stage, the branch. By the way, when we start doing proper stuff, we will not be writing the code here. We're going to be writing it in Visual Studio Code. So it will be easier to kind of manage these curly brackets. It's just doing my heading, but it's good to just start small first and then see. So stage, and then we're going to stage display, Terraform init. And then this is what we're going to do. We're going to say dir and all steps rather. So dir Terraform, which is a directory. And then we're going to open it up. And in here, we're going to do sh Terraform init. So this is what we're doing. So that should be it. And then let's see, we're going to be second time lucky. Okay, my fingers crossed. I'm going to keep an eye on the machine here. So then check the machine here, because I suspect that it would give me some grief. Okay, let me check how much memory the system is using. Okay, memory is good. Okay, quit. Okay, now let's have a go. Okay, now build now, and then the problem probably starts. It's still responding. I think it looks good for now. So let's see. Yeah, at least else failed. Okay. She's good, at least doing something. Okay, cool. So Terraform, no such. What is it saying? Okay. Terraform, no such. Terraform. Adding Terraform code. It's the same. Message property. Okay. All right. Can anyone guess what the problem is here? Let's see.
Can you help me search for error? Just search ERROR.
I want to see if you guys are following.
Okay.
That's the arrow.
No,
Let me show you the code. Maybe that'll give you an idea. Okay, let's look at the code together. Maybe that gives you an idea. Okay.
Yeah, let's look at the code.
Figure out.
So pipeline pipeline terraforming it. Directory terraform.
The directories, the Terraform, is it not supposed to be in quotes?
Thank you, sir. Fantastic. You got it.
Yeah.
You got it. So this is just saying directory needs to go. Fantastic. So we're not out of the woods yet because we didn't get here. So now, again, to the risky move. So I'm just gonna see if I'm gonna lose the machine again. Yeah, just want to see. When the machine dies, and I press enter, it won't respond again, and I know I've lost the machine, and I suspect it might happen again. But let's see. So it's running now. Call me a man of little faith. I suspect that this would, okay. It's still going, still kind of going. Okay, it's successful. Okay, and the system is intact. Okay, that might just be because we have a memory system. So guys, I don't want to experiment and try a T3 again and then see it fail. So I've tried a T2, T3 small. Initially, we tried a T3 micro that died. You might have the same experience. If you do, let me know. Because I normally would use a big system, you see. But obviously for this exercise, it makes sense to use a free tier system. So try a T3 micro. If that fails, let me know. We might have to do a T3 small, but if that doesn't work for you, then it might make sense to go spin up your instance somewhere. But I don't want it to be too, what's the word? Pessimistic. Go for it first. If it fails, then I will tell you what you need to do. It's not something I want to cover in class because it might be complicated. You might need to do a bit of surgery, and that will just mess up the class. But hopefully you won't. And if you have got the money, just do it because you're not going to learn too much. You don't want to be doing all this little surgery. If you've got the money, if your T3 micro crashes or hangs, just go a T3 small. If you haven't got the money, just ring me. I will help you set it up with the micro, but we're going to have to do some little tweaks here on that. It will be a lot of Linux stuff, and it might be a bit advanced. And it's not worth teaching. Otherwise, we're going to be here for like a long time.
Is it
Okay,
possible
cool.
to use another region? Can we
I
use
don't
another?
think I don't think it's region issue, right? It's a machine capacity issue.
Yeah,
So it's
because
been Mhm.
US is 2. I see C7 large as free tier.
Look at that. That is a great call. If your T7 large is a free tier, please use it. Because look at your region. That's a great one, bro. Look at the region, look at whatever is free and it's huge and use it. But first and foremost, just do the normal stuff, T3 micro. If it dies on you, then look for another free tier. It will tell you which one is free tier eligible. And if you're stuck, please call me. I will do my best to unblock you. Because I don't want it to be like an issue if it's not an issue. Like obviously people are already preferring solution that the one Kate just told us now, which obviously is a very, very viable solution. So if you want to switch region and you get something better, by all means. Okay, cool. So the unit actually works. I'm just trying to recollect my thought because we'll deal with an unexpected problem. It comes with the territory, by the way. So this init works. Able to do init for our Terraform code. So the next thing we want to do is probably do a validate. The thing with Terraform, okay, let's do validate. You will see what I mean. So I want us to kind of deal with the problem as they arise. So the Terraform init is done. So next stage is let's move to validate. So that's first stage. That one here. So I just want to do a copy to make it real quick. Okay, so let's do validate. Okay. Let me check my temp directory just to be sure. DNS Edge. Okay, time is good. So Terraform validates. Let's do this one. Apply, save. Here now. And then we can take a peek and see what is happening. So doing validation. Okay, Terraform validates is succeeded, so everything is cool. It likes the code. In the next stage, what we do is Terraform plan after validation. Okay, the plan will fail, definitely. And we're gonna then, I'm gonna explain why it failed, and then we're gonna kind of find a way to resolve the failure. I don't want to do it, and then you will not really appreciate why we're doing what we have to do next. Okay, so the next stage will be Terraform validation. By the way, before I run the validation, let me show you something real quick. So we've done these things, init validate, and obviously Jenkins is doing all this for us as an automation platform. I did say to us that we could have done this ourselves. I think it's worth repeating that. We could have done this ourselves, and of course we don't want to go that route. Let's see. Okay, so this is the repo, right? We've done the, let's find ourselves here. We did the Terraform init initially, which kind of works well, right? Okay. The init came back, okay, the init is done, and then we'll do the validate. I'm just repeating what the system has done for us. And then I want to, before we do the next one, and we did Terraform validate, obviously the code is here, right? The Terraform code is here. And then we did Terraform validate. This is just to check the code because we're running validate. And then tell us the code is valid, etc. The next thing would have been done will be a Terraform plan. Okay, Terraform plan. Now, Terraform plan will fail. The reason why Terraform plan will fail is because it needs authentication. So I'm going to kind of repeat that. So this will fail because it's saying I can't connect to AWS platform, etc. Okay. What we would have done in real life is I would have gone on the system and then do my export here and there to make it happen. Which is export my keys, etc. So I'm going to replicate that here on the pipeline. You will see the same issue, and then we're going to apply, so validate. So we want to do the Terraform plan. Okay. And then we'll call it Terraform plan, and then we'll say plan, and then we expect this to fail with the same kind of issue we saw when we ran it on the console. And then we can check. Okay, stand plan, blah, 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 validate is good. And then plan will fail. Okay, so plan has failed as expected. You can see it's literally the exact copy of what we saw. Because about credentials, it's not there, blah, blah, blah. In real life, what we do when we have this problem, remember, in real life, what we do is we go here and we do that little export that I always do. So let me see, hopefully my key is still valid. I will do an export here. I'll say export this, export my keys, export my access key and region and all the rest of it. And then export my default region as well. and then I will then do Terraform plan. But I try to always safeguard my keys. I always disable it. Let me just enable it back, otherwise it won't work. You won't have to do this. It's just a same mechanism I use just to make sure my key is not overly exposed. So you may not have to do what I'm doing next. It's just basically enable my key. I always disable and enable it. So it uses backups. And then go to security. So this is my key. Activate. I always deactivate it. So activate it back, otherwise it won't work. So you won't have to do that if you didn't deactivate your own key. I didn't do that, the key won't work. By the way, I need to do this export, and then my plan should work now. Remember what I'm doing there doesn't have any bearing on what is happening in the pipeline. I'm just showing you replicating what the pipeline is doing on the console, which you're already familiar with. Now, plan would work or should work. Let's put it that way. Okay, we can see plan works, which is what we expect. Okay, now again, if we run this here now, it doesn't have any bearing with this. I just want to basically establish that before we do it. So we build now, we will still get the same problem because nothing has changed so far. Okay, let's see. See, it's build again, the same problem. Okay, so we know what we need to do. We need to do export in here as well. Okay, so we need to go here and then do the same export, what we did here, which is export. All these ones, we need to do it here as well. Okay. So we then go here. We'll go to pipeline configure. So the way you do exports is using what we call environment. So it's where you set up environment. What does that mean? So let me tell you, show you a little secret in Linux. So anytime you do an export, which what we've done a lot of export this, export that. If you type env command, env, which is environment command, you will see all your exports. Let's see. You can see access key. We can see secret access. So whatever you've exported will be in your environment. And that's how Linux is able to figure stuff out. So you would do the same thing and set up your environment variables here within the Jenkins framework. So all you need to do is just say environment, which is basically export. And then we set it up here. So what we're setting up is literally what we've done here. And I'm going to give us a little bit of caveats to it. So we will do, if you see this here now, if I can find it real quick. Okay, that's one there. So this one is down. Let's copy that. So it's literally that. So it's SOPS access key. Copy that and just do this. Do this. This is not a safe way, but this is where we start. AWS secret access key, and then we'll do the key ID as well. I want to give us the basics first before we kind of do it the way we should do it, so that it will all make sense to us. Okay, this is what we had yesterday. Always try to give a reason why I'm doing stuff, so that's not just that. That's how it's done, and we don't have an explanation for it. Okay, again, I'll separate this and just make it look nice. Okay, and then last one, hopefully we'll find it, which is the region. That's not terribly important, but it's just to make sure that we dot the I's and cross the T's. One copy. Yeah. So this is literally export as far as what's it called? Jenkins is concerned. This is doing an export. Anything you put in an environment is an export. So this should help us. It's not the most ideal way, but it should help us. So let's get on with this now. Apply, save, and then we'll run. Here now. And then let's try to peep and see where that takes us. Okay, now this looks good. You can see now because of the keys, everything looks good. Right. But nobody writes a pipeline this way. I'm gonna tell you why. So if you go back to configure, of course it looks good, but this is a no. You shouldn't put your key in the pipeline. It's risky, it's unprofessional. So what you do, you tuck your key away and you look it up. For example, this secret access key, you tuck it away. You don't put anything here. You use what we call credentials plugin. So the idea is you go and keep your key somewhere in Jenkins, and then you look it up, so that no one will be able to. You won't have to reflect your key in or anything secret in here. So how does that work? The way that works is you go deep inside Jenkins, somewhere else, and then you go here to manage Jenkins. Let's ignore this scary stuff. And then you go to credentials. And then you click on system. And click on that. And you say add credentials. Okay. Now there are also credentials you can add. So in our case, the credential we want to add is a secret text. Okay, it's a secret text. And then we'll get a secret, which in this case is the first one. Please don't copy the single quote with it. Just copy here to the secret there. You have to give it an identifier. Sometimes I just paste this one here first to make sure that I copy the right thing. Start with X, end with U, because sometimes this is the problem you have, and it take a long time to figure out you not copy the right stuff. So I always copy here with X and U, and then go verify again. X, U, then I know it's good. So I can just give this, and then I can call it, I will call it AWS access key, AWS secret access key, something like that. I'll just do lowercase AWS-secret. That was literally this, but in lowercase. Or you can give whatever name you want. So, but you have to give it an ID, because that's the ID you're going to use to look it up. So I will call mine AWS secret access key. And that's how I'm going to remember it when I look it up. So AWS. And that gets created. I'm going to copy that. Create. And then this now can then be replaced by saying credentials And I'm just going to put that identifier there. And I don't need this anymore, so I don't have to show it. Okay, same goes for this one as well. Copy, go back here, and add in my credential, and obviously secret text again. I'll put the secret. Again, is worth checking to make sure you have not done anything A and B. So I'll say AB. AB looks good. And this will be my AWS access key ID. So I'll say AWS access key ID. Okay, access is C, I suppose. Okay. And then I'm going to copy that. You get the gist. So you can go on and do the region as well. The region is not terribly important, but you can look up region too. But I won't worry about that. But there's nothing stopping you from making that credentials as well. Okay. And this is it. And then we'll run this again. It's same thing. I won't expect anything to change. Apply, save, and then build now. And then we can begin to take a peek. We expect this to go each free. Okay, this looks good. All right. So now we are at this stage. Everything kind of looks good to us. We're good to go to basically apply our plan and all the rest of it. In reality, we're going to apply Terraform apply. Don't expect this to, okay, so let's say we're on like a normal system, okay? Terraform apply would have just applied the code. So we said plan, we know plan work, apply should work as well. Two things we apply. So let's say apply. Apply would do what plan does, but you would say you want to go ahead just to get some confirmation. You can see this is what it's going to do. And then it will say, do you want to continue? And you will say yes, and then you will go. Right? Let's say no this time, just to stop it. Okay. Now, we're going to do the same thing here, but two things we need to understand with the way automation works. So currently now, we want to run this in an automated fashion. So we don't want Terraform to block, because now when you run it, this question that is asking, it's going to ask it in an automation, what's the word? In an automated prompt, it would try to execute the Terraform apply. Also, that is when you are running Terraform. Terraform will try, Jenkins to run Terraform apply. It will try to apply it, but it's going to hang. The reason it's going to hang is because it's going to go into a prompt mode, requesting a yes or no answer. But that prompt, you will never have access to it because that prompt will exist in the console. So we just see that the code will just hang. So you see here, it would hang and you will not be able to access it. I think it's worth demonstrating first. So you see. And then we're going to look at the certain remedies that we need to have in place. Okay, so, all right. So what do I mean? So we go back here and then we'll extend the pipeline again. You can see now inevitably it's getting bigger, but it's making sense because we are doing it step by step. So there's nothing magical that we're doing here that is that we're just building on it, literally. So we do the Terraform apply now. So apply, so apply, save, and then we build now. And I expect this to hang because we will not be able to say yes or no because that thing will be kept in the console. I will not be able to access it. So this will just hang. Okay, so because, okay, it's saying, do you want to talk? Because it's basically, it's in like a console approval mode, it doesn't like it. And that is why it's basically just canceled it. Because instead of, I think they've improved this, usually the old version of Jenkins, this hangs because you can't access that yes or no prompt because that is happening on the background. And that is why this will just crash or hang. And that's where we're getting what we're getting here. The reason for this is there's no way to say yes or no against the console. So whatever you want to decide, you would have pre-planned it and you would have sort of applied the decision you want to use, essentially. So because you will not have the option of saying yes or no against the console here. So the way it works in reality is I'm gonna go with the easy way first, and then we go with the most ideal way. So what you do here is you do the plan is good, so when they apply, you would just say auto approve, and that will be the approach. Okay. Now, when we auto approve, if the pipeline is good, everything works. Remember, this is just Jenkins following his rule to apply your code. So your code, you're as good as Terraform would, Jenkins will not forgive whatever Terraform mistakes you've made. So if you've made the wrong thing, Jenkins doesn't understand. It's just basically applying Terraform command to your code. So if your code is not up to scratch, it's not Jenkins' fault. In my case now, I think I might have some problems with the AMI. I don't think I have this AMI. I think this was created a while ago when I was teaching how to use Parker. I don't think this area exists. I'm going to check so that when it fails, we know why it fails. So AMI 56. Let me check that real quick. Maybe I have it. Okay, all my AMIs are gone. Okay, so this would fail potentially. So let's have a look. It's not a big deal. If it fails, it fails. That's the AMI that I'm reflecting in my Terraform code, which I don't think is the default AMI. Let me check again. Let's see what the default AMI is. If I was getting a 3 micro, whatever. Oh, sorry, Amazon AMI. I'm not launching anything. I just want to see it. Okay. So if I was picking an AMI, okay, so if I go with this one now, so this one is a 2025, blah, 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 so which is not the AMI. So this will fail, which is fine. It's just to understand that, you're as good as your code. Terraform doesn't really, sorry, Jenkins doesn't really give you anything different. So we apply this, auto approve should get us to where we want to be, save, and then we'll try to apply it, and then it will just basically fail because it won't be able to find the AMI. Stepwise kind of showing this makes sense so that if you run into any of this problem, you can hopefully trace your way back and see how we managed to get past that issue. Okay, console output. So the auto approve now, we're not getting any failure. Okay, now it's failing because you can see it will tell you what the issue is. The AMI does not exist. We expected it, right? So saying I can't find the AMI, so I probably will then update my Terraform code to reflect the right AMI, and then we'll take it from there. Okay, so I will go and just get an AMI. So this one is this. This is literally, let's copy this one, try to use this AMI. And then I need to go and update the Terraform code. So I'm just going to do it here, but you can use your Git normally on your machine to do your edit. Or if you still have your AMI that you want to change anything. So in my case, I will change this, write the new AMI, and I will come in the change AMI. Okay, it knows about it. Update change. Okay, and then if I run this code now, then we'll go back again. Terraform will do a new pull. So go pipeline, build, and then we'll have a look. The validation should be good. The plan should be good. And auto apply should now be good. Now I see it's creating. And it's good. This is all done now. We've got our node, everything is created. Should be able to check and see a new instance launched. Okay. So we've got instances. You can see that is Terraform. This is the new machine that we've created. So it's good. So this is there. And that is the very first huge victory we have. This is all right. But there's a little fly in the ointment, and I'm going to show you what a fly in the ointment is. It's a little bit of a wrinkle. Okay. Now let's pretend that I run this code again. So the pipeline, say you make a little change and you happen to have to run the pipeline again. Right? So you go pipeline, you want to run it again. You would expect that, because the machine is already created, it should just say the machine is created. I don't want a new machine. But let's have a look and see what happens. So output. Okay, cool. So this is good because it knows that the infrastructure is good and there's no need to make a change. Why is that so? That is so because this is very, very important, and you might see this problem later on. I'm not going to dwell on it too much now, but there's something that is happening in Terraform that we should see. Let me give you an instance. So this is good because now we look at this and let's see. And then we see have just one instance, no matter how many times we run the pipeline. Okay. Now, the way Jenkins behaves is by default, it will look, if you don't have any new change in your commit, it will just basically use the old repo where it's kind of doing things internally and it will not do any deletion of the repo. That won't make sense to you now at all. I get that. But let me do a little demonstration to kind of try to explain the next concept we're going to look at and why we need that concept. So now, this is all good. No matter how many times we run this pipeline, we're not going to inadvertently generate new node, which is not what we want. But let's pretend I go back to another interface here, remember? And so this is another, I'm not using a pipeline, I'm using the console for whatever reason. I do a git pull to get the new updates, which is the change I made with the AMI, and I do Terraform apply somewhere else. And then maybe auto approve as well. Let's see what happens. You can see it says it's going to add one. It's not updating. It says it's going to add one. So let's see what happens. Okay. What's happened? So if we go back here and now refresh this, we've ended up with two node, which is not what we want. Okay. Now again, I'm gonna even make it more interesting. So we go back. So we are in this directory. Okay. Let me move away from this directory. Okay. Or let me go back. And then let me go back one more step. This is me on the machine. And I do in here we have the clone, right? So I'm gonna remove this clone, rm-fr, classic, remove. I'm gonna do a new clone. Seed into 8. And ls, seed into Terraform. I'm gonna do Terraform init. So this is me recloning the repo. I'm trying to make a point. Don't worry, you might and what am I on to? You'll see what I'm on to. And I do plan, and just, and plan is gonna tell me same code. It's gonna create another new machine and do apply again. And then inadvertently, I will be creating 3 machines instead of just holding on to that one that I wanted the system to create for me. Okay, so if I go back here and I refresh this, I'm gonna have ended up with 3 machines. See? Now, here's the little magic. So if I then go back, same directory, if I run apply again, I'm the same directory. If I run apply again, it's gonna say, yeah, I know you have one, and there's nothing to change. But God help me if I move away from this directory and I download the code again to another directory and I run Terraform apply, I will end up with the 4th node and the 5th node and the 6th node. So the theory is, in as much as I remain in the same directory, the system will detect the machine that has already been created. If I move it to another new fresh direction, I do a clone, then the system will assume that you want to create a new machine and you end up creating a new machine. So in as much you maintain the directory where you are, you don't run the risk of inadvertently replicating the nodes you want to create or manage. Or what's the mechanism behind that? So this is a little secret. So anytime you run Terraform, there's a few directories created. So you have the main code, which is the Terraform file, which is the one that's doing all the magic. You can have a look here. That's the code here hasn't changed. Let's clear the screen. Let's do ls-0 here one more time. So you have the main file, which is there. And then you have the .terraform directory. This is the directory where anytime you do Terraform init, this is where you would copy the Terraform plugin, maybe for AWS, maybe for Azure, whatever else things you need, get copied to this directory. However, this file is called a state file. And what's the state file? Let me show you a command. Terraform show. Show. This construct. This don't die on me, please. Okay. So Terraform show. What Terraform show does is it just shows you the state of affairs. So where is it? Terraform show. It just shows you the state of affairs on your Terraform without you logging into your Terraform on the console. You can use the Terraform show and it will tell you what else is going on, your subnet, whatever else you see here. You will see it by Terraform show. Okay, how does Terraform show work? The secret to Terraform show is the state file. So if you do ls-tra, you see the state file here. If you have a look at the state file, let's cut Terraform state file. This is what is in the state file. It is like a reference point or a database for your Terraform code. So Terraform would keep the state of the machine it created. It will keep that state here. So what happens is when Terraform wants to execute, it will compare the state file here to what it sees on the cloud. So for example, if there was no state file, it will assume it's a fresh machine creation. If there was a state file, it will look at the content of the state file and see what else it needs to change. Let me give you an example. So this currently now we have a state file, right? We have the state file, right? And our Terraform code, in this case, we have a machine that we are creating and it's called Terraform Nginx code. Let's say I update the machine name, let's call it Sunday Tonic, something like that. We just change the name, we change it to Sunday Tonic. Okay, this is a little change. If you look at the state file, so let's look at the state file. And then the old name was Nginx, something like that. You can see the name. This is the name that Terraform knows, the old name, right? And that is in the state file, okay, which is, it's like the blueprint. The state file is different from the code. The state file, what have the last thing Terraform did. If you do a new apply now, I'm not going to auto approve. You will see that it would contrast what you have in the code, which is I have updated the main code, and I will contrast that to the Terraform state file, and it will say, I've noticed the change. So it's comparing the new code update to its own reference point. Can you see that now? It says, yeah, there's a change. It's going from Node to Sunday Tonic. It's noticed that, but the way it's able to do that is because he has a state file, and is using that state file and matching that with what is on the code and what is on the platform. The state file is very, very key to Terraform. Without the state file, it's like a shoe without a compass. You will not know where it is. The state file is very, very important. So if I say yes now, this will not create a new machine, but rather I will update the existing machine on the system. So if we go here now, I will refresh. You can see now we're not having a new system, we have Sunday Tonic. Okay. Now, the last experiment. Okay. We're going to change this Sunday Tonic to Weekend Tonic. So vim main.file Sunday. Let's just change Sunday to weekend. Okay. So I will do that. Right. Now we're going to add an extra thing to it. So I'm going to remove the state file. So we're going to throw away the compass of this Terraform code. I'm going to remove Terraform state file, everything. State file is gone, and then we're going to do apply. So we expect it to do an update, right? So I would say apply. Because it doesn't have a compass, it doesn't have a reference point anymore. It's going to create a new machine. It's not an update anymore because it doesn't have a reference point. This looks like a new machine to it. And then it will end up creating a new machine, which is not what we want. So the whole point of this experiment is the undeniable importance of the state file. So we can see weekend tonic being created. Okay. And yeah, so that's the nature of the beast. Okay. So the state file is very important. So let's say, for example, in this pipeline process, for some reason, maybe our pipeline becomes too big and we begin to purge our pipeline, or we create a new pipeline, so which we can do actually. Let's do that. So we have a new pipeline, right? So this is a old pipeline that we've been working with. Let's say we go Jenkins. This is the old pipeline. We then create another pipeline. So we say new item. Okay, we can copy the old pipeline and then we can copy from the old pipeline. We can just say copy from, let's call it pipeline 2, pipeline 2. And we'll say copy from, what's that pipeline called? I think, let's see. We'll create a new pipeline. Let's see what the old pipeline is. From pipeline. I want to create a new pipeline. I want to use another template, copy from Terraform pipeline, which is that one. So we create a new pipeline. So that will be the new pipeline. You can see it's just a copy. Right. If we go execute this now, we're going to end up with creating another system. Okay, so obviously that will download this code, which still saying Terraform node from the GitHub. So we're gonna end up with maybe another new what's it called? Another Terraform Nginx node number 3 potentially. Okay, which is probably not what we want. So we go here. Created a new repo. We just did a copy of the existing pipeline, or we gave it a new name. You can do that. If you already have a pipeline you want to replicate, you can just say copy from, and that creates it. Then apply, save, have a new pipeline 2, we build. It's fresh, it's new. Because this is running off a new directory, it would not see whatever's happened in the other directory, which is that something was already created. So they will end up creating a new machine, which is not what we want. But because they are not able to share their state file, because they are running off different directories, you're going to end up with a new machine to like pipeline number 3. Sorry, Terraform, whatever, Nginx code 3. You can see that. And that's not what we want. So the only way to ensure that the system will not inadvertently be recreating stuff and being out of sync is to ensure that there's a way to keep your state file intact. So the state file will have to be in a location where whenever you run your Terraform code, you will be able to access the state file, and maybe it's running on a pipeline, it's running on a machine. You need to be able to tell it where to find the state file. Obviously, if you're running your code on a single machine, you can define a location where the state file will be kept, and then it would not matter. It will not matter. The location was. It will not matter if it's running. The system is running from different pipeline. In as much they are able to reference the state file. At a specific location on the system, then they will not inadvertently be out of sync. So instead of keeping the state file in a subdirectory where the stuff is running, you might define a global directory, so to speak, where you are able to essentially point the system to your state file and then use it from there. So how do you do that? So first and foremost, let's do okay, so let's update the code a little bit. So I'm just going to let me just test the code to make sure it works first, and not going to put it here. So the theory of it is this. It's very easy. Okay, so we have the code here, right? And this is not on GitHub. This is local on the machine. This is what the code looks like. GG. So normally when you start your Terraform, you start with Terraform, you do all the require provider, blah, blah, blah. One thing you can do is Terraform bit. You can define what we call backend. Okay, you say backend here. Okay, just kind of taking cognizance of time. Let's say backend is local. Okay, and you can define where you want to keep your state file. Okay, And then you're gonna say path equals. Let's keep this one in temp. Let's create a directory called quick test. And we're gonna keep this state file. We're gonna call it let's not make it too complicated. We'll just call it Terraform TF state. Let's call it that. Okay, so that's the only change. And this is what this is saying is the test file now should not now exist in the subdirectory. Should be in a location where potentially everybody can see on this machine though. Okay, that's the only change we need to make. Let's do an init. You might not like it because the state file has moved. Okay. Okay, do you want to copy it? Yes. Okay. This is saying, okay, now I know you've made a change to your state file. Okay, it doesn't really do anything, but the beauty of this is now that wherever you run your code, it would know that the state file, it's no longer a subdirectory here, was being moved to it would move it to the temp directory. So if you say apply, the state file now is moved, and that will be centrally controlled in temp. And this is how things would work. Some CMP form state file, you can see it lives there. So for example, now with this code now, so let's do pwd. Okay, let's remove this. Let's go back to steps 1, 2, 1, 2, and let's remove the directory classic, and let's do a fresh clone. Let's now go into classic Terraform. Okay, then add the Terraform in it. Now remember now, oh, sorry, because I am not, I think I lost the code because I didn't do it in here. So I didn't do it in here. So I should have done it. Let me just do it here. So I won't have to be, I've forgotten about it. So let me edit this one. Okay, I'm just gonna do it here. I'm gonna do, okay, edit. I'll do it backend. I'm gonna say it's local. I'm gonna specify a path. I will say the path is TMP Terraform or on this TF state. You can give any name you want, but it's always the convention, you know, and that's it. And then we'll save that. Okay, commit. And then let's go back here. I'm going to just do a fresh pull. Because I already cloned it, so let's pull it and get the latest. Yeah, it's there. So if we cut it, we'll see it there. Okay, now we'll apply. Oh, let's do init anyway. Terraform init. Okay, so now Terraform apply. You can see now it's not doing anything. Of course, because we said change turning to tonic, that's fine. But how is he able to know this? He's able to know it because the state file is still intact. We'll say yes. because I think we didn't change this. This is this in Nginx, that's fine. So the point here is the state file now, it outlives this system, okay? So if you say yes, you apply it, blah, blah, blah. Now let's delete again. Let's say we lose this, okay? RM plus FR, RM, FR, sick, clone, CD. Okay, so back in there, I've just removed it and then brought it back. Now everything is gone. If we do init again, so the point I'm trying to make here, because the state file is kept outside of the directory where things are changing, it doesn't matter. It outlives whatever cleanup you're doing. So if you do apply, and then it will tell you there's nothing to change. Because even though you cleaned it out, because the state file is not living in that directory. So whatever is changing there, it doesn't matter. So that is how you would manage it with Jenkins. Also, remember, it doesn't matter which pipeline you create. So let's see that in action. So the only problem is that, okay, so I'm looking at the time. Okay. Well, I think I've changed this now. Yeah, so you can reference this when you're doing your stuff. I can use Terraform state file reference and use it. That would help you to avoid unnecessary replication that would inadvertently happen here, because the state file is locally managed by default. As you can see, if you go to the console, let me show you one more time. Console here. So anytime you run your pipeline, okay, this is where things will run, because this is still happening in Linux. It's just that Linux created a different location for for Jenkins to operate. So if you copy this and you go check, if you're very curious, ls -ltr first, you can see this is what Terraform is doing on this magic. Oh, sorry, Jenkins doing all this magic. And this is where all the drama is happening. So the state file, everything is here. If you do Terraform, okay, you can see this is where it's keeping the state file. And then if you check the other pipeline also, which is called, I think we call it Terraform something pipeline. And then you go in there, you can see the Terraform directory. You can see that, and you can see where the state file is stored. And the problem with this is the state file is not shared, and that's why there will be replication. But if you then define your code and say the state file should not be kept as a file in a subdirectory, but global on the machine, then you will not run into the problem of each thing keeping its own state file. Obviously, the downside to this is that, if you're not careful, you will not be able to recreate machine. Let's say you want to create a second machine, a third machine, you want to use the same code, you're gonna have to point your state file to different places. Otherwise, you just said the machine already exists. And that is the downside. But obviously, if you want to run your pipeline many times and manage your state file, you want to keep your state file in a location that outlives your pipeline subdirectory. The way this is done in real life, it's a little bit different because, currently now, what we have now is this state file exists, it lives on a machine. If this machine dies, let's say this machine freezes as it's frozen the other time and we lose it, that state file is gone. Also, you might have a different guy somewhere, maybe in maybe imagine if you're working for a global company and they are using different tool server and you're running the same code. Some people run the Jenkins file on the server A, some people run a Jenkins file on server B. But this file is machine bound. They will not share the same state file, and then you will then have a problem of creating new machines because the state file is local. In reality, the way you want the state file to be managed is you want it to be managed in the cloud, somewhere that is central, and is not on one machine, but in a central location in the cloud, such as a disk that is outside of the machine, but any machine will be able to access. And we're going to look at that next week to kind of see how we can even make this better by not making the state file. We've seen that we don't want to make it directory bound. We've done that, but this is still machine bound. It still exists on our tool server machine, but we're going to update this to make sure it is not stored on a machine, but rather in a central location outside of a machine that at any point at any time, either you run on a local machine, either you execute your Terraform on a local machine on some server A, some server or server B, in a small state file is central somewhere in the cloud, then it won't matter where you're running. You will be able to access that state file and then will know the exact state of affairs. Currently now, this is good, but it's still limited because this state file only exists on one machine. And if we lose the machine or we run the Terraform code on another machine, then inadvertently we're going to end up with a new machine created, which is exactly not what we want. I think this is a great place to stop. I'm going to open the forum for questions and comments. The nature of our task for this week will be that it's still an extension of the fruit task week 5 task. So just for this week, what we're going to be doing is we're going to be creating our machine with Terraform. Okay, so I want you to also try to see if you can use Parker to do your work. So you Parker to generate your AMI image, obviously using Jenkins, and then also using Jenkins to drive your Terraform to create the machine from Parker. The last bit is not what we've covered in this class, which we're going to cover next week, is how do you then run your start your web application, start your Java application, start your Python application remotely. We couldn't cover that this week. I think we've gone as far as, how you create a machine. So you should be able to create your machine using automation. But the next step, which is, now setting your Jenkins to, setting your Nginx to work, setting your Python to work, setting your Java to work, you will still have to do that manually. But the creation of the machine itself, try to use Jenkins for your Packer management and your Terraform management. We're going to see how we're going to manage the third leg, which is now instantiating and running those applications on the platform next week using automation. Thank you very much. Any questions or comments before we wrap up? Oh, by the way, before we go, so if you finish your work, try to do one more thing, which is Terraform destroy to destroy your instance. That will be here. I'm going to share this code so you can see it, and then you can leverage it. So where is it? Configure, and then try to do destroy. It's just the same as apply. So when you finish, obviously not now, because if you destroy it, then it's gone. So you can just say stage. It's literally the same thing. Just say destroy or clean up when you're done, and then say Terraform destroy. And this will help you clean up the whatever you created. But if you do it, then you will not see your machine because you apply and it will destroy. So you have to be ready to destroy and then update the code at that point and then destroy. In as much you keep your state file like this, you should be good. But don't destroy until you are ready to destroy. And then this will just auto destroy, just extend it to destroy it for you. And that will just clean up the machine and will just automatically delete it and do all the cleanup necessary. So please remember that. I guess that's it. If you don't have any questions.
I do.
Okay, go for it, sir.
Yeah. It's actually not a question, it's just a quick observation. because I ran into a problem maybe 3 years ago. The when you were exporting, that was actually when I raised my hands, but I put it down again. When I saw your secret key, I saw /, and if it was a backslash, that would have escaped the next character, because in Linux, backslash is used to escape the next character. If that was it, and the way you've exported that key, I just said it's an observation, that would have escaped the next character, which would have, as in invalidate the key that you are pushing. So if you are not observant, you might think you're copying the right key, but not knowing that within the context of that key, there was a backslash, which is actually escaping the next character, which is wrong.
Okay, I get what you're saying, but it doesn't apply here. I know what you're saying. So
If you look at that key,
I know what you're saying, but what you have to, in as much you are not putting your keys directly on the machine here, you won't have that problem. So what you have to do is, ideally, nobody should be putting their key on this machine. Key comes with all sort of character, funny character, X, Y, exclamation, blah, blah, blah. Nobody should be putting their character keys in. It was just to demonstrate, the steps we are taking to get to the finish line. Credentials should never ever be in your code. So you put your credentials behind the scenes on your platform and then you look it up. So if you do that in the best way, you will not run into the problem of, backlash, first class, escape. I get what you're saying, but it will not be a problem.
I understand what you're saying, but if the way or I've been taught by one of the best teachers, which is you, we need to run it locally first without even you are doing everything together.
If you're running locally, then you won't have that problem because that will not be Jenkins, right?
So if you export, because I've encountered, I just said I should point it out so that it took me about 2 days to figure it out, because my secret key had a backslash, and you actually figured it out, not me. And that's why I'm trying, because I never forgot when I had that issue. So I'm trying to just say that so that someone will not find themselves in that same situation. So I'm just bringing it out, because if your secret key have that and you're trying to replicate, because you have to build it manually first before you automate. This is automation using Jenkins.
Okay, Kole, because of time, so we're gonna have to wrap it up. So I get your point. Obviously, the key could cause all sort of problems. So you cannot really envisage every problem you're gonna have. And as you basically rightly alluded, experience comes with having issues, dealing with them, and then building on that. So it's almost inevitable that people will run into problems, and that will make them better engineers. Because you are talking from experience now, and I know what you're saying. Yeah. So I think that the only way to deal with this is to practice, run just all sort of problems, and then it makes you a better engineer if you're not a quitter. I know that people here are not quitter. I know it's you, maybe Cynthia, people that I've worked with in the past. And that's why you guys are still doing DevOps. So that's the spirit. Any other questions? Thanks, Kule. Alrighty. I hope this class hasn't scared you yet. So it gets easier. As soon as we get through this, we're gonna get through Ansible, and then it should be smooth sailing. Any other questions?
Yesterday we are 10, now we are 8.
Yeah, it is well. All right, guys. Have a blessed week. I will share these things and have a good one. Thank you. Bye-bye.